Okay. Let let box x denote the largest integer less than or equal to x. Okay. So any number, any real number x can be written as box x plus fractional part of x, right? So this is the largest integer less than or equal to that number, and this is the remaining fractional part. Okay. So for positive real numbers, it is quite simple. 2.567. For this, box x would be 2, and fractional part of x is 0.567. For negative real numbers, box x is -3, because you are looking at the largest integer less than or equal to this. If you take -2, that is more than this, so you take -3, and fractional part of x would be 1 minus 0.567, that is 0.433, right? So remember that this is always between 0 comma 1, these 0 and 1 not included. So suppose here your greatest integer function is such that, so greatest integer function is n plus f, where n belongs to z and f belongs to 0 comma 1, suppose, just for this problem's sake. Okay. The real roots of the equation, this given equation, are lying in the interval. So we are already told this equation has real roots. So we have assumed what? We have assumed box x equals to n and fractional part is f, such that x is equal to n plus f. What is the given equation? What is box x? N square minus 2 times n plus f minus n plus 3 equals to 0. N square minus 3n plus 3 minus 2f equals to 0. So see this. This side, this is a quadratic expression with n as an integer. Since n is an integer, this must be an integer. That means 2f must also be integer. F belongs to 0 comma 1. That implies 2f belongs to 0 comma 2. So this and 2f is an integer. This means 2f is equals to 1. That is the only possibility. The only integer between 0 and 2 is 1. F equal to 1 by 2. Right? So if you substitute 2f equals to 1, what you will get?
Sir, for
Mhm.
f we'll also have close bracket on 0 now.
Why?
Sir, the
Okay. It can, fractional part can be 0.
yeah,
Okay. Okay. So what you are saying is 2f can be
0
either
and
0 or
1.
1. Okay. Very good. 0 or 1 by 2. So this is the possibility. Okay. So there are two cases now. So the first case is in this case what will happen? N square minus 3n plus 3 equals to 0. Now what is the discriminant of this? B square minus 4ac, that is 3 square minus 4 into 3 to 1. 9 minus 12, which is less than 0. Which implies this does not have no real solutions. Yes. And this is exactly why we are given that the quadratic has real roots. So f cannot be 0. So case 2, f equal to half n square minus 3n plus 3 equal to 2f, that is equal to 1. N square minus 3n. Solving this, we will get n equal to 1 comma 2, which are real. So x is equal to n plus f, that is 1 plus 1 by 2 or 2 plus 1 by 2, that is 3 by 2 or 1.5, 2.5. In the given intervals, both are contained in only this intervals. That is your solution.